So the homework for this will be a PDF, okay? And this will get included on the quiz, which is like next Wednesday, okay? We'll include this stuff. So we're doing surface area of prisms and pyramids. We will go back to cones and cylinders. We had actually this note in, not this slide, but the one next to it, in the notes from last week, and I told you we would skip it, we'd come back to it here. This is us coming back to it. So what's the difference between lateral area and surface area? Lateral area is the sum of the areas of the lateral faces. So this does not include the base. That's the difference between lateral area. Surface area is total area. So you will see those two intermingled. It'll either say find the surface area or it will say find the total area, but it means the same thing. The total area is the sum of all of the faces and like all the lateral area plus the base. Yep.
Isn't a base a face though?
It's not a lateral face though. So it is a face if you're counting your faces, but the lateral faces are the non-base sides. So if it's because you can do this for different shapes, but let's say it's a rectangular prism and we say the front and the back are the bases, then the lateral faces are all the other sides. It's this one, the left one, and the bottom one. If I were to claim the top and the bottom as the bases of this, then the lateral faces would be front, right, left, and back. If it's let's say it's a pyramid, then it's a little bit more obvious because your base is obviously that base is the bottom. And in this case, it could be a square, yep. And then the other 4 sides that connect the base of the vertex, those would be your lateral faces. So like on the pyramid, the base is the bottom, right? So the base area would be the area of that base, like the bottom, plus the lateral would be all of those triangles on the top. On the...
It's not the volume.
Correct. This is all area.
It's the outside only.
Correct. Like if you're covering it in wrapping paper, the surfaces that you're covering it would be the area.
How do you find the lateral area?
Good question. In a prism, the lateral area, you could literally find the area of all the bases and just add them together. I mean, all the lateral faces and add them together. Or, I'm about to get there, you could use the formula, which is pH. P is the perimeter of the base. H is the height of the prism. So P times H, where P is the perimeter of the base and H is the height of the prism. And then total area, you have 2 choices. Lateral area, if you already found it. So if I found the lateral area, I would just add the 2 times the base area. If you didn't find the lateral area, then you can use what lateral area equals in its place. So 2b plus pH. You could use either one of those.
Why are we multiplying 2 times the base?
Because there are 2 bases in a prism. Yes.
Wait.
The definition of a prism.
Or the base is the...
So if you're looking at the prism, you get to pick what sides would be your bases. The rectangular prism, it's not already predefined, right?
Front and back, your top and bottom.
Okay, so pick one.
Top and bottom.
Top and bottom. So if the top and the bottom are your bases, then when I find B, it'd be of those, right? And then there's 2 of those. So it's 2B plus the perimeter of the base. I would add up all the sides times the height of the pyramid, of the prism, which would be any of those corners. And that's your pH. If you look at the next one, what kind of prism is this? It's a triangular prism. So the bases have to be the triangles. I'd find the area of the triangles. That's your B. It's 2B plus the perimeter of the triangle. So I'd add up all these sides. And then the height would be one of these segments that connects the bases.
Okay.
Good?
And for that one, it would be the hexagons?
Correct. Yep, so you'd find the area of the hexagon, that's your B. You'd find the perimeter of the hexagon, that's your P. And then the height would be any of the segments that connects the 2 hexagons. All right, so this one, rectangular prism, right? So it breaks it down for you to find all of these parts.
Keep going.
All right, so it breaks it down for you to literally find the perimeter, then the base area, then the lateral area, then the total area. Sometimes it's going to go straight to the end, okay? But this one actually breaks it down. So if I want to find the perimeter, it's the perimeter of the base. Pick one pair of sides to be the base. Which one?
Top and bottom.
Top and bottom. If you did front and back, your perimeter might be different, your base area might be different, your lateral area even might be different, but the total area should always end up being the same.
No.
So if we pick, what'd you just say? Front and back?
I said top.
Top and bottom. What's the perimeter of one of those bases? It'd be 2 times 4 plus 2 times 2, or 8 plus 4, which is 12. What's the area of one of those bases? 4 times 2, or 8. The lateral area is the perimeter times the height. So perimeter of the base, which we already found is 12. And the height of this prism, if we used top and bottom as the bases, then the height is 6. Good. So this is 72. Good. And then the total area is 2b plus, we already found lateral area, or 2b plus pH. You could keep it that. But I'd get 2 times the base area, which is 8, plus the lateral area, which is 72. 16 plus 72. 88. And these are all, well, the base, this is centimeters squared, centimeters squared, centimeters squared. Perimeter's the only one. That would just be centimeters.
On the graded test, are we gonna have to, do we choose the perimeter, like, do we choose the base, or the base is gonna be chosen for us?
No, you could choose a base. And so that's why you could get a different answer. Like this, if you picked front and back, these 3 are actually going to be different. But we'll know both answers. Yeah. But the area, the total area at the end should be the same no matter what. And if it's not a rectangular prism, then it has to be the same. Because there's only a specific kind of base. Say that again. You could pick any side. Is that what you mean? Yeah. You could pick top, bottom, front, back, right, left. So it could have. No, if you're doing front and back, you still have to pick the base area. Yeah, you still want the base area. All right. What kind of shape is this?
That is a triangular prism.
This is a triangular prism. Good. So the perimeter of the base, which ones are the bases? Top and bottom. Those triangles have to be the bases. So the perimeter, on the top they give you 4 on one side, and the bottom they give you 4 and 3 on the other side. So if I add those 3 together, good. Base area, this is a triangle, so it's 1/2 base times height. Now we're talking base of the triangle, which was the 4. And the height of the triangle, which they also give you, is 2.8. So this would be 2 times 2.8, or 5.6. Lateral area is perimeter times height. The perimeter was 11. The height of the prism is 6. So 66. And then the total area is either 2b plus pH or 2b plus the lateral area. 2 times 5.6 plus 66. 11.2 plus 66, or 77.2. Centimeters squared, centimeters squared, centimeters squared, and just centimeters for the perimeter. Questions on that one?
How'd you get?
7 is the apothem on the, what is this? This one's a hexagonal prism. So this one goes straight to total area. I want to do 2B plus PH. The base is the hexagon this time. So 1/2 ANS. 1/2 the apothem, which is 7. The number of sides, which is 6. The length of each side, which is given as 8. This is 48. I can cut it in half. That's 24 times 7, or 168. Now, P is the perimeter of the base. So if the side lengths are 8 and there are 6 of them, what's the perimeter of the base? 48, good. And what's the height of the prism? 6. So 336 plus 288. 624. Because it's 8 and there's 6 sides. Like one side length is 8 and it's a hexagon. That's the length of each side. So it'd be 8 plus 8 plus 8 plus 8 plus 8 plus 8, or 8 times 6. And they didn't give you a unit. If it showed it, it would be unit squared, like that. Units squared. I don't think so. We haven't made it yet, but I don't think so.
No.
Questions on that one? All right, now we get to pyramids. Lateral area for pyramids have 2 options. One, and this is if it's a regular pyramid, you have these 2 options, okay? The first method is find the area of one of the lateral faces and then multiply by the number of sides, because they would all be the same. Again, only if it's a regular pyramid. So if the base is a square, or the base is a regular hexagon, or if the base is an equilateral triangle, you could do it in either of these ways. You could find the area of one of those slanted triangles and then multiply it times the number of sides on the base. The second method is using the formula 1/2 perimeter times the slant height, where P obviously stands for your perimeter. The slant height is as though you ran a line from the vertex to the center of the side on the outside of your pyramid. So the slant height runs, the slant height runs down the side of the pyramid. There is one slant height for each side that's there. Like this one's obviously just drawn here, but it would also be this way, and this way. On a square pyramid, there would be 4 of them, and you could find any of those. Now, this is where things get a little bit trickier because they won't always give you that slant. You gotta just wait just a minute. They don't always give you that slant height. So you are forming several different types of right triangles. There's a right triangle formed by the slant height, half the side length, and this edge, which is called your lateral edge. So sometimes you're using that right triangle to find one of those missing side lengths, okay? That would be on the exterior or along the side of it. The other type of right triangle that can be formed is from the height to the side, so this would be half your side length, to the slant height. So this is when pyramids get a little tricky, is that they will normally give you 2 of those measurements, but sometimes you've got to find the third. So one triangle, again, is the slant height, half the side, and the lateral edge. So slant height, half side, lateral edge. And then the other one is the height of the pyramid, half the side length, and the slant height. That's like an internal triangle. Okay. If it is not a regular pyramid, then if you wanted to find the lateral edges, lateral faces, or the lateral surface area, you'd have to find lateral area. You'd have to find the area of each of those triangles and add them together. So if it's not a regular pyramid, then you have to find the area of all those slanted triangles and then add them together, okay? You couldn't use these methods. All right, total area, which is again the same thing as surface area. You'll see those interchanged. The surface area of a pyramid is the base area plus the lateral area, or base area plus 1/2 perimeter times the slant height. Notice there's only one B because there's only one base. And instead of using height, you're using slant height. Height gets used for volume, but slant height gets used for area.
Hey, can you go back to the slide I believe?
Yep, just a second. And then the total area, if the pyramid is not regular, you literally have to find the area of the faces and add them together. So if my base is not a regular polygon, which we're going to get to one that's like a rectangle, you'd have to find the area of the faces and the base and add them together. All right, this one says a regular square pyramid has a base edge of 6 and a lateral edge of 5. Find, and there's all these parts. My advice is probably draw it out for those of you especially that are visual. So when I draw a square pyramid, I start with the triangle in the front, kick the one to the back, and then literally try to draw yourself the square on the bottom. Doesn't have to be perfect, okay? If you wanted to go to Google and save yourself a picture of a square pyramid, you could do that too.
Someone's more talented than you.
Agreed. So the length of this, well, first of all, let's label what we've got, is the base edge is 6. So this is 6, this is 6, this one would be 6, this one would be 6. All the edges of the base. And that already tells me two things. One, I could find the perimeter, and one, I could find the base area. Then it says the lateral edge is 5 centimeters. So each of the lines that were drawn would be 5. So if I want to find the slant height, which would run diagonally down the side of your triangle, what does it do to the side length being 6? Cuts it in half. So this is now 3. That's a right triangle where the hypotenuse is 5 and a side length is 3, which would make your slant height. What's your triple? 3 blank 5. 3, 4, 5. If you didn't know it, then you'd have to do 3 squared plus the slant height squared equals 5 squared. Slant height squared would be 16, and your slant height is 4. Triples never go away. Okay, lateral area. You've got two options. One is find the area of one of those triangles and then multiply it times 4. The other option is the area of a lateral. Lateral face is what? What's the formula? Nope. Nope. 1/2 PL. So 1/2, what's the perimeter of the base?
24.
24, right? There's 4 sides and they're each 6. So 24. And what's the slant height?
5.
Nope. 4. We just found it. Stop getting distracted by your game. It will be easier. So my lateral area is 48. Again, I could have found it by finding the area of one of those lateral faces, one of the triangles, and then multiplying it times 4. You would have gotten the same answer. The base area, how do I find the area of the base? What is the shape of my base? Good. It's a square, so it'd be 6 squared, or 36. The total area, I could take the lateral area and I could add the base area to it. That's one way, right? Just add them up. My formula is B plus the lateral area, or B plus 1/2 PL. Any of those ways gives you B 36 plus lateral area 48. and I get 84, and I don't have a unit. Yes, I do. It's centimeters squared. It's either B plus the lateral area or B plus 1/2 perimeter times the slant height. Yeah, PL. Questions on that one? Okay, now last one is the altitude. Altitude is the height of this pyramid. So if I drop it, that wasn't very good, but let's say I drop it right down to the center of that square. I go to the right. That measurement is half my side length, which is 3. I come up the side, and that's the slant height.
So basically, you could say it's a right triangle.
It is a right triangle, which is 4. But instead of the hypotenuse being 5, the hypotenuse is now 4. How do I find the height?
Pythagorean theorem.
Good. So 3 squared plus h squared would equal 4 squared. H squared would equal 7. So h is the square root of 7. You would have to do that if it wanted you to find the volume, right? Volume would be 1/3 base area times height. So if I wanted to keep going, 36 times square root 7, I'd get 12 root 7. That would be if it asked for volume. So if it asked for if it asked for areas, you need the slant heights. If it asked for volume, you need the altitude or the regular height.
Why was the hypotenuse 4 and not 5?
Because this time you're turning it on its side. Like, so the triangle formed is the height, half the base, and the slant height. Whereas the first time, the lateral edge is what was 5, not the slant height. Okay. Questions on that one? All right, example 5. A regular triangular pyramid has a slant height of 9 and a base perimeter of 12. Find the following. So lateral area is 1/2 perimeter times the slant height. Base area is going to be the area of the base plus the lateral area. No, sorry. The base area is the area of the triangle on the bottom, and it's equilateral, so it's 1/2 ANS. And then total area is the base area plus the lateral area. So start with your lateral area. Do you have enough information to get the lateral area? Yes, right? They gave you the base perimeter is 12. And the slant height is 9. So that's 54 centimeters squared. I didn't even need the picture.
The rectangular triangle pyramid is
Huh?
the slant isn't the edge, right?
Correct. So if I'm drawing it on the triangle now, the slant height would be coming down the side like that. That would be 9. You don't know it yet. Yeah. So if I want to find the base area, this is my equilateral triangle, right? So I have I'm just going to turn it so I'm looking at it. The equilateral triangle has a perimeter of 12, which means what's true about each side?
They're equal to 4.
They're each 4. So if I want to find the area of this equilateral triangle, I can either find the height of it, like that, or I can do what we've been doing, which is that 360 divided by 3, which is 120. That's the central angle. Cut it in half, and it's 60 at the top. This would be 2, because it's half the side length. And now 2 equals a root 3. The apothem is your A. I'd have to divide both sides by root 3. I'd get A equals 2, and I'd rationalize it root 3 over 3. And that's the apothem. So then I'd get 1/2 the apothem, 2 root 3 over 3, the number of sides, which is 3, and the length of each side, which is 4. The 1/2 and the 2 cancel, the 3's cancel, and my area is 4 root 3, my base area. To me, that's the hardest part. If you can figure out your, like we've done it a couple sections, but it's going to keep coming back. Equilateral triangle. So then C is the base area, which is 4 square root 3, plus the lateral area, which is 54. If this answer said keep exact, that's literally how I would answer it. If it wanted you to round it, I would do 4 times the square root of 3 plus 54, which is 60.93, if it wanted you to round it, centimeters squared. So just pay attention to directions if you're going to round it or if you're going to keep it exact. Okay, last one. Uh-oh. What kind of pyramid is this? Rectangular, which means it is not regular, which means you can't use those formulas on it. So if I want to find the total area, what do I have to do?
You have to calculate every side.
Good. The good news is, like, if it's a rectangle, the sides, there's going to be 2 of the same. Like, the front and the back and the right and the left are going to be the same, right? But I do have to find I'm going to have to find the areas 3 times. So the base area would be 11 times 5 because that's a rectangle. Length times width. That one's not so bad. The forward, let's say the front facing and the back facing, those are triangles. So area would be 1/2 base times height. The base of that front triangle is what? The base of this triangle. Well, the base is 11. You're going to do half that, so you're on the next step, but yes. Then the height of this triangle is 10.3. So multiply that out, and that's 56.65. There are 2 of those, the front and the back. So you could do 2 times that, or you could literally add it twice. Yep, same thing. And then the last sides that we don't have are the right and the left, which are also triangles. On this side and the left side. What's the base of one of those sides? 5. And the height of one of those sides? 11.4. So each one of those is 28.5. So you could either add it twice, multiply it times 2, or not, cut it in half. Same. So 55 plus 56.65 plus 56.65 plus 28.5 plus 28.5. And you get 225.3 yards squared. So keep in mind, when you are dealing with a base that is not regular, you cannot use the formulas. $225.3. I hear you, bud. Questions? All right, so tonight's homework is a PDF. You got to make sure you show the work, okay? It does say, and then I'll answer, obviously I'll release the solutions tomorrow. It does say, like, the 1 through 3, it says to skip them. We've already done them. It's the stuff from, like, Euler's theorem. Just skip 1 through 3 and then start with the rest of it. Again, make sure you're showing your work. All of them require work.